may or may not recall the strategy. We're going to let our variable x here be not the price or not the unit sold. I'm going to jot this down over in the margins over here. So we're going to say let x represent the number of price increases. So x equals 1, increase the price once to $6. X equals 2, increase it to $7. Maybe we find out that x equals 0 is the best you can do and $5 is the best. We could also find that maybe decreasing the price would be the best idea. In that case, we would just get a negative number for x. So how does that help us set the problem? We're going to take this equation for revenue and we're going to make a function in terms of x. So these all set up the same way. So once you do a couple of them, you'll just have the idea. You'll have this example to go back and look at. But how do we get an expression for the price? Currently, Janelle charges $5. But a general expression for the price, taking into account the increases, would be 5 plus x. You could also think of this, I'm going to actually just in pink write a 1 in here. And you can put 5 plus 1x or 5 plus x. I'm not your dad. Do what you want. But this makes sense for the price. Say if x is equal to 5. Well, that means an expression for the price is $5. And then you increase the price 5 times and you get 10, which makes sense for the price. For the units sold, currently Janelle sells 100. And then every time she increases the price 1 time, she loses 4 dozen cookies of sales. So we'll have 100 minus 4n. Why minus? Because her sales go down. Oh, I used n. We're using x. Apologies. Let's fix that up. All right, so can we just digest that? Are you guys okay with where that come from? If there's one price increase, 100 minus 4 is 96. She sells 96 dozen. This is a quadratic function, and then luckily you guys have either learned or have reviewed how to find the vertex of a quadratic function, but it's not in the form yet where we can pick off our negative b over 2a. We just got to do a bit of, you guessed it, expanding and simplifying. So can you guys do that? I'll do it too. Why not? So 5 times 100, 500. 5 times 4x. 5 times 4 is 9, evidently today. 5 times negative 4, negative 20x. 1 times 100, 100x. And then minus 4x, 1x makes minus 4x squared when you multiply them. And then I like writing my squared term first. That way there's no confusion, picking off your a, b, and c. And we just got to add the like terms. Plus 80x plus 500. All right, everybody can do this. It's now in a form where you guys are familiar on how to find the vertex, and we just got to use our skills from last week, find the vertex. So I'm going to do my attendance while you guys use our axis of symmetry formula and find the value of x that corresponds to the maximum revenue. And I'll play catch up in a second. Make sure to pause the video. All right, and we're back. Let's see how you guys did. We have a ton of space for this problem, so just off to the side, I'm going to jot down my A, B, and C. Even though we don't need the C, I'm going to write it down. Putting the terms in order is important, so you don't mess up which one's A, which one's B, which one's C. And we're going to find our axis of symmetry by using negative b over 2a. I'm showing a lot of work here. So we have negative 80 divided by 2 times negative 4. Negative 80 divided by negative 8. So that gives me positive 10. Did you guys get positive 10? I see some nods. All right, we're kind of done the question. What we have just found is that x equals 10. Remember, x is the number of price increases. 10 price increases will maximize her revenue. You guys can just do the mental math. If she's charging $5 and she increases the price 10 times by $1, she should charge $15 per dozen to maximize her revenue. But let's jot a few things down here. So what does this mean? This means increase the price 10 times. Remember, x is the number of price increases again. So increase the price 10 times to $15. And if you're wondering how we got $15, we're just using the original data. It was $5, and then we're doing $1 price increases. If it was 10-cent price increases, 10 increase would be $1.50, but this is $1 price increases. And this will, in order to maximize revenue. So that actually answers the question, because the question, no, that answers part one of the question. What price should she charge? We just found that out. Sometimes that might be the end of it. This question wants us to find what is the maximum revenue. So you guys just have to find out what is the value of the revenue, what is the value of R when you put in x equals 10. I'm going to use the my expanded revenue function. You could use the original factored one. That would work. That would work fine as well. Can we do the mental math here? That's minus 400 plus 1,300. I think that's 900 would be her maximum revenue. So very interesting. So she's going to lose some customers, but in the end, originally she only made $500. This time she'll make 900. So if all things are the same in terms of her costs, she'll make a bit more money. So that is an optimization problem involving revenue. They all set up in a similar way. You expand, you use the axis symmetry. Anything you guys want to chat about? All right. When you guys are doing your assignment later, you're going to set up a couple of these. You have one to go by. All right, let's look at our second question here. So I showed you guys how to set up the equation for a projectile. It was always -5 due to Earth's gravity. The number in front of t is always the speed. The number in front of the number at the end is always the initial height. So I don't know if you guys are, I might be dating myself. You guys might have been like 5 or 6 when the bat flip happened. So, but we're going to model Jose Bautista's bat. So you can imagine like the center of mass of his bat as he flips it in the air after hitting this big home run. We're modeling the ball. That's no fun. Anyway, the speed of the ball, 30 meters per second off the bat. And when the ball was hit, it was about 1.2 meters above the ground. So after last week, my expectation from you guys is that you guys can create a function that models the height of any projectile. It's always -5t squared, -5 for gravity. Maybe in some cases, to be more accurate, we'll use -4.9, but -5 works just fine. And then you guys fill in the blanks. 2 blanks to fill in there. I'll have a quick sip of coffee. Now, as you guys are filling in those blanks, we've done a revenue problem. We're finding the maximum height of a projectile here. On Friday, we found an optimal speed to minimize gas costs for a truck. Anytime you guys read max or min, maximum, minimum, you guys are thinking find the vertex. All right. I stalled long enough. What are we doing? I don't even know. What are we doing? Where's my pencil tool? Well, there's the eraser. There it is, drawing. So did you have this? Did you have plus 30t plus 1.2? everybody can set up equations for projectiles. All you need is the speed and initial height. And then, what this test on Thursday comes down to, there's really two things. We've used the quadratic formula, and we've found the vertex. Now, the 3U people, we've also done a bit of work with radicals, and we learned about the inverse. But in terms of the two skills with quadratic functions, it's either one or the other. You guys, a common thing I'll see on our unit test is, given a problem, people can set up the equation okay, but then they might find in this scenario, they might use the quadratic function here. But we're interested in the maximum height. So when you guys read the word maximum, you think vertex. You should be conditioned like Pavlov's dog or something. Maximum height equals vertex. And we've literally done like 17 finding the vertexes together. So let's do it, and we'll finish things off here. Get you guys working. So the axis symmetry will be at negative v over 2a, using t here for time. So this is going to give us the time when we reach the maximum height. If you want to jot down your ABC somewhere where you have space, we have a lot of it. So we get negative 30 divided by 2 times negative 5. Now I've cooked these up to work out to nice whole numbers. Not always the case, but we'll take it. Negative 30 over negative 10 is exactly 3 seconds. This isn't the maximum height. This is the time it takes to reach that maximum height. And now you guys can finish it off, finding the height after 3 seconds. You know what? I'll just do it with you guys. So minus 5 times 3 squared plus 30 was our initial speed times 3 plus 1.2. Whatever that is. Can we do the mental math today? Maybe. I believe that would be 46.2. 46.2. Is it 46.2? All right, now you guys have me doubting myself. Minus, okay, yeah, I'm getting 46.2. All right, and this is our maximum height. It's like the Y value, maximum height. We are done. So you guys can do revenue problems. I showed you how to set those up. You guys can do projectile problems. I've shown you how to set those up. But any question, Andrew Sullivan, you with me here? Any question that says find a maximum or a minimum, you guys are good. You just find the vertex. So if you're trying to find the max minimum, find the vertex. If your problem requires you to solve an equation, I might even just add in brackets here. I'll say, or like x-intercepts. In that case, you guys are using your quadratic formula skill. You just have to kind of be able to choose which one to use. Like in this lesson right now, where the lesson is literally called problem solving with completing the square. So we know which one we're doing. On your unit test Thursday, I'm not going to have a heading saying completing the square questions and quadratic formula questions. You guys have to practice enough to be used to when to use each. All right. Going to wrap up the video.